So hello guys and welcome back to our channel. So what we would look into today would be working with message queues, and specifically I would like to introduce you to a software called NATS. So we'll do a little bit of introduction to working with message queues, and of course we're going to really focus on NATS, and then I can show you how to set up a server as quickly as possible, and then we can talk a little bit about publishing and subscribing to messages, and then we would actually look at real examples as to how one can handle asynchronous tasks with NATS. So NATS in itself is a high performance messaging system that allows publish subscribe pattern of messaging. So it's really designed to be lightweight, pretty secure and easy to use. So it's really an excellent choice when you're building modern distributed applications. And of course, it also supports various programming languages, which of course includes Rust. I also did a video in the past where I did an extensive example of how you can work with NATS in Go, and I will also add a link to the description if you'd want to see more practical use of NATS. And I'm probably just going to bring this over here so you can actually see what we're talking about. So I will also add a link to this web page, but it's really pretty straightforward, nats.io. And over here, you can actually read up what you could do with this. So it has a lot more you can do, not just like working within a, let's say, given application to offer you like a distributed kind of architecture. It's of course, as you can see over here, multi-cloud to edge and setup. That's a lot more you can actually do with this. Again, I'm going to leave a link in the description so you can come back to this and check it out when you have the time. So what we will do now is to actually start working with NATS. There's really no point to waste so much time. So what I'm going to do next would be simply set up a server. So NATS, of course, is written in Go, and it's actually pretty easy to work with. There are a lot of possibilities that they offer as to how you can work with it. So you have the option of running this as a single standalone application, say within a Docker container, and you also have the option to actually embed this into your server, specifically when you're working with Go. I am not sure if this is possible with any other language. If you will have to work with any other language, you mostly have to run this, say, on a separate container and then have your application interface with it. But with Go, it is really possible to embed this within the server. And again, this is extensively explained in the Go tutorial, which I did in the past, which I, of course, also leave a link to that you can check it out. But what I've done also is to really just go ahead and download the binary. Again, I'm going to leave a link where you can also, of course, get the binary to the server. And what I'm just going to do over here is pretty straightforward to start it. I already have the binary in my path. So what I can now do is I can say nats server. I can also maybe add the help flag, and then you can see what's sorry, what possible or probable more or less flags you can actually add to the CLI application, of course, when you have this installed or downloaded. So you have the option, of course, to specify the address, and this mostly defaults to .o.o.o, and the port is mostly 4222, and so much more other things you can actually set up here. Again, we down here we have Jetstream. So within Core is actually um, NATS is more or less split into two major categories. So you have NATS Core, and then you also have Jetstream. Jetstream is more or less what you probably would do when you've explored all there is to do with NATS Core, and but it's because it offers a lot more functionalities where you can actually do things like object store and stuff. And so, but most times it's actually advisable to first start with NATScore, see what's offered, and then this is not enough. If you require more functionalities, then you can actually go to Jetstream. So again, there is option to, of course, do authorization. You can do a lot of different, can work with using password and of course auth tokens. A lot more things here you can actually check out. Again, I'm going to provide you a more detailed description so you can read these things up. But for our own case, it's going to be pretty straightforward for us. So you definitely use most of the default parameters, and then I can simply say nats server, and that's actually all I need to do. Again, I don't need to provide at least for this use case, like an address and a port. So that's why it's also using the default values, as you can see over here. And it also creates a default user for me, so you can also see like the credentials up here. But for now, I want us to keep it pretty simple. So what we would now do is, as you can see, we have the server running locally, and what we would try to do now would be to try to connect to this server from our Rust application. So for now, this is of course not protected anyway. We are not doing any form of authentication or authorization, and we're just like really connecting to it directly. So because again, I don't want this video to be quite long, the documentation is actually pretty straightforward and quite detailed, so you can take a look on your own free time. So, but for now, let's really go ahead and start working with this. I'm just going to bring this down again so we can start working with it. So the first thing I would like to do is to show you like a really easy example how you can connect to the NAT server to publish to a given topic, and then also how you can subscribe to that same topic from like using, of course, another connectivity format, so that way you can actually consume the messages, because again, like I said, it's built in to be in sync with the pub sub module, so you can actually have multiple publishers, and of course you can also have multiple subscribers. So I'm just going to come to our main file, and then we can actually start running some. I'm just going to close this up so we have more room. And then so what I would like to do is maybe I can comment our cron part out, because I don't want to clutter the whole space. We really don't need this for now. So let's really focus on what we're trying to achieve. I've gone ahead to add the dependency we require in our cargo toml. That's also what I say here, async nuts. And now we can actually just start adding some code up here. So again, remember our server is running down here. So what I will try to do is to connect that server, and then, like I said, publish and subscribe to certain topics to consume the messages. So I can define a variable here. I can call it nuts URL. And again, I'm assuming we have something set in our environment variables called, maybe let's call it nuts URL. Because I try to make it as modular and generic as possible, so that if, for example, you have this running within a Docker container, you would, of course, it would not make sense to hard code these values. So I can do unwrap or else. So if this is not set, which is definitely going to be the case for us, if this is not set, then I'm just going to default to the default URL. So that's going to be at nats colon, and then I go to localhost. Again, remember I go to now port 4222. And then I'm just going to convert this to string, and that's mostly it. So now we have our NAT URL. If this is not set, we'll default to this. That's really what we are doing here. And now I can create a client. So the client is going to be really pretty straightforward. I'm going to get this from async nats, and I can simply say connect async nats, and I can say connect. And now I pass, of course, the NAT URL is an async function. It returns a future, so now I have to await it, and then I have to handle the error as well. So now, for now, I'm just going to do an unwrap, and now we have our client. So at this point, if this server is not running, then we would have an error here. But that's also why I started this server before we actually get to this point. And now what we'll actually do is I will try to create two functions. So one of the functions is just going to be an async function. We'll spawn up a new task within the Tokyo ecosystem, and then run a single task that's going to constantly publish to a given topic. And then we can also have another async task constantly consuming those messages. So we can actually really come down here and create two functions. So I'm going to create two functions here. I'm going to call the first one, it's going to be an async function. I'll call it send to nats. So this is going to be our publisher. It's going to be a function that takes a client. So this client is going to be of type async nats client, and it's going to return a result. Sorry, it's going to return a result, and it's going to return either this or of course an async nats error. Pretty straightforward. So again, now we just implement our logic. It's actually pretty straightforward. So to send or to constantly publish to our or to a given topic, for example, I would like to have a loop, an infinite loop more or less. And then within the loop, I'm maybe just going to create a list of possible um, topics or subjects more or less I would publish to. So I can say something like for subject in, and I'm just going to create a list of vectors. I can call this easy dev dot topic one, and I create another one because this is supposed to be a string literals actually. So I create another one. It's going to be easy dev topic two, and I create another one. Maybe if I stop here for now, I'll say easy dev dot topic three, and so we'll loop through more or less these subjects, and then we'll simply publish our message. So I can say client.publish. It's really that simple. And then we'll provide two things. One is a subject and the second one is a payload. So for the payload, we can, again, this is going to be our subject, and the payload, we can say something like, I don't know, hello from easy dev, something like this. And of course, we have to await this because it's an async if it runs the future, and then we handle the error as well. And this is supposed to be okay. We can do dot into to take care of this for us, and then maybe what I can actually do would be to come down here and maybe sleep for a while. So I can say Tokyo.time dot sleep, and I need to provide the duration. So Tokyo dot we go to time, and then duration. Then I can say maybe from seconds, and I can say maybe sleep for 5 seconds so it doesn't really just bombard us with messages, and then we await this. And then maybe I can say here I can just drop a message, and I say something like maybe I use my info, and here I can say something like completed sending cycle, something like this. So this is just going to constantly send more or less 3 messages to this topic. To these would be of course the different topics that's going to publish to. And then the next thing that I would like to have, of course, is to have a function that's also going to constantly read from these topics. So again, it's going to have this same signature. So now I'm just going to copy this, and now I can say maybe receive from nuts like this. And then this also, again, is going to be really pretty straightforward. So I can say I want to create a subscription. So this subscription again is going to be pretty straightforward. So client.subscribe is pretty straightforward. And now here we are going to use like a wildcard more or less to match all those topics, because if you look over here, they all start with easy dev the topic one and such. So I'm just going to copy this. So this is going to be our topic. And what did I do? Actually, easy dev. And now what I can actually do is say dot asterisk. So now this is going to match every of the topics that start with more or less easy dev. And now we have our subscription again. So I would like to create an infinite loop, so this constantly listens to our messages. So I can say why let sum. So if we actually have a message, we can call this MSG is equal to subscription dot next dot next dot await sorry, so handle this like this. So we constantly listen to our messages. What is the error here? Okay, of course this has to be mutable, so I'll make this mutable. And so we constantly listen to our messages, and for now, again, you can consume these messages whichever way you choose, but for now I'm just going to actually print this message to the screen. Okay, so I'm just going to say something like this. And I can say, so this is going to be our subject, and I can say received message on. So again, here I can provide maybe the subject itself, and oh, come on, has to be inside of this. And so now I can actually do something like because now I simply just want to show the payload and the topic from which we got the payload. So in here I can see something like std, and then I go to str for string, and then I go to from utf-8, and in here I can simply pass a reference of my msg.payload. And of course, I need to pass one more thing, and that would be a reference again of our message, that's subject. And that's really all I need to do here. And what else? So now what I can actually do is to maybe come down here and spin off two tasks. So those tasks are just going to be Tokyo tasks. That's just going to run in the background, more or less on a different it's going to handle, of course, this different async tasks for us. So we can say Tokyo spawn of a new task, and in here I can, what did we call it? So send to nuts. So this would be send to nuts, and I can pass the client. I might need to clone this, but let's see. I think we would definitely need to clone this. But let's see, and then this would be receive from nuts. And so maybe let me see also if we can actually pass mutable values here. Also, maybe to keep it pretty straightforward, what I can simply do is maybe come over here and clone this. That's also totally fine. And then, but our focus now would be that when we run this function, this should constantly publish messages to these topics. And then this would constantly would subscribe to all three topics, and more or less using this wildcard, we'll be able to match all topics that of course start with EasyDev, and then we can consume those messages. So let's test that out and see how things are looking for now. So now I can say cargo run, and then maybe I expand this so we can see. So you can also see how we get the information. We are connected to this NAT server, and then these messages are being published, and here also we are writing the messages that we get. So if I stop the server, as you can see, we get this message that is disconnected, and then I can also start this up one more time, and then we see that it's connected back. So this is like the very basic thing we can actually do with this. And now I would like to show you like an interesting thing we can do with this. So this would, I believe you would actually find much more useful than the simple example we just shared. So one interesting example I would like to show you would be to provide you with a scenario whereby we can have an exposed endpoint that does a certain thing, for example, and then based on maybe the outputs of the operation, it could be able, or it should more or less be able to publish a certain message to a certain topic, and then we could have another aspect of our app subscribe to that topic and then maybe decide to do something else. So this could be again one way we could like facilitate more or less communication within our app. And so, but to do that, maybe the first thing I would like to do would be to modify our app state. So I'm going to go to our app state over here. And maybe to even make this interesting, I would like to start with actually wrapping this DB pool connection here in a mutex. So I'm just gonna bring in use std sync, and I bring in the mutex. And so now I'm gonna wrap this in a mutex. Um, and now we would get some errors, as you can see. I would have to come over here, and now we can say something like, maybe after this point, I would like to create a new, I would like to shadow this variable again. I can say pool equal to mutex dot, I hope this, let me go up. Okay, I have this imported, so now I can actually say mutex dot new, and then I'll of course pass my pool, which I have already. And now this should be fine. So, but we have a couple of endpoints already that depend on this pool, which we have within our app state, and that's also why we are having some errors here. So, like this place. So again, that's also totally fine. So here we can actually say app state dot pool. You can say dot lock, and then we unwrap, and that should be fine. So I'm just going to copy this part. That's actually all we need to do, because now, like I showed you, this variable is now within a mutex. So again, I just put that in here, and this should be fine. I can also put that in here as well, and it should be fine. So let's just go ahead and put it everywhere actually. And one more place would be this. And so we now have this out of the way. Again, I'm just going to get rid of this guys, so it doesn't, we don't have a lot of all these files open, and then it becomes a little bit confusing for us. Anyway, so let's proceed. So I would like to actually add two things to this app state, and one of them would be an async client. That's going to allow us to, we can do whatever we want to do with the client. We can decide to publish, we can decide to, but mostly for our endpoint, for example, we can actually just, I would like us to just use this to subscribe, because again, we would need to terminate at the end of the request, would of course need to return to the client. So it doesn't make sense that we run a blocking process. So mostly we'll just use this to say publish to a given topic. But of course the client can be used to do both. That's just what I wanted to clarify. Okay, so I can add another variable within our app state, and I can call it nuts. I can say nuts con, so because, or maybe I say nuts client, because that's exactly what it is. And again, it's going to be of type async nuts client. And I'm going to put a comma here and a comma here as well. Of course, we're going to get an error from our main file, but that's also how we're going to fix it later. And I'd like to add one more. I would also like to add maybe the possibility to work with channels as well. So I can have another thing here, and I can call it sender, for example. And this is going to be of type MPSC. So I'm using Tokyo Sync, I think. Let me see. And so now I can, of course, do sender. And then within here, let me just say I'm just going to be sharing strings actually. I'm just going to add a comma here as well. And now, again, maybe what I would also want to do just would be maybe to wrap this again in a mutex. And this one as well, I'm going to wrap this also in a mutex. Let me see, mutex. Okay, so this is what our new states would be looking like right now. So what we would need to do now would be to, of course, update our settings here for our app state, so we'd have this available to all our endpoints, and we can do whatever it is we'd want to do with them. So the first thing I would want to add here would be maybe set up our MPSC channel. So I can say let's, of course, we get two things back, TSRX, and this will be coming from our MPSC, and I can say channel. And so I'm just going to maybe add a buffer. I'm just going to make it 100. So this is going to be the buffer size. And of course, I'll need to provide the type of data I would like to share, of course, within this channel. Again, you have the option to even make this a struct or whatever, it doesn't really matter. So, but for our own case, I would like to just share a string. So the string is just going to be the kind of data we share, because again, if you remember what we set up in the app states, this should be of type string. So that's also what we have to do over here. So with this setup, I would like to now maybe define a sender. So this is going to be of type mutex, and I say new, and then I'll pass my of course tx, and this is going to be my sender. And now the next thing, of course, I would like to set up would be like our connection, our client, more or less. I think we called it NATS client. So that's also the next thing I would like us to set up. So coming down here, so what I can do is because we have this defined down here, so I'm just gonna cut these guys and come up here to redefine them more or less. So this, of course, would still be exactly how it is. But now what I would like to do is I would like to define a variable here, and I call it NATS client. This NATS client is really going to be actually pretty straightforward. What I would simply do would be to clone this our original client, and that's really it. So again, just to confirm, we called it NATS client. So I would like to call it that exactly as well over here. So now we have our nuts. We have everything more or less actually we need to set up our new app states. So now I can go ahead and provide those. And of course, I also need to, again, like we defined, I also need to wrap this again within a mutex. So I can maybe call this actually client 2. And then down here, I can now define my NATS client, for example. And my NATS client will now be, again, a mutex.new. And then here, I would simply pass my client. I'm just going to leave it as simple as this for now. And now over here, I can now, of course, pass NATS client and which one again? Sender. And our app state should be fine. And now what I can actually now do is to take this client 2 and then bring them over here. So this would become what I passed to all those other functions. So again, if I restart this server, everything should be fine. And we should still be able to, of course, see the messages that we saw before. So now to use the setup, which we already did, one thing I would like to do would be to create an endpoint which is going to, I don't know, do some things for us. And then in the end, we're going to publish to a given topic. And then we would have a function which, of course, constantly listens to that topic and then be able to consume the messages, subscribe to that topic more or less, and then be able to consume the messages coming into that topic. So the first thing I would like us to do more or less would be define this topic. We want to see what it could look like, and then we'll move ahead to the endpoint. So I can come down here and again create a function. Is really going to be similar to what we already have. Actually, I can copy this one. It's going to be exactly like this. And then, but I change this name. I'm just going to maybe call it handle nuts messages. Again, is going to take a client and then, of course, return either nothing if everything is okay or an asynchronous error. So in here, maybe what I would do would be to differentiate them both. So I can say async def easy def 2. So the endpoint that we would create in a short while would publish to this given topic. And then this should be able to consume those messages for us and then, of course, give us the output. So again, this is actually pretty straightforward. We are done. So now what I can actually do is to, again, come up here, copy this, or maybe I copy this one, doesn't matter, and drop it down here. And then I'm just going to copy this function and then replace this with that. And then this is fine. We already have this hooked up. It's really that easy. And now what I want to do is to come to our handlers and create a folder. And I'm just going to call this nuts. And then inside of here, I'm going to have a mod.rs. I'm going to write everything in here actually. And then I come over here and I say pub mod and nats. So in here for now, to keep it simple again, so this video doesn't get longer than necessary, I will define the endpoints and everything in here actually, and then this should be fine for us. So the first thing I want to do is I would like to define a struct that's going to define the kind of payload I expect to come into this endpoint. So I have a struct, and I don't, it doesn't even need to be public actually, so that's also fine. So I can say struct. I can call this nats rec. So this is going to define, of course, the request that would come to this endpoint. There's just going to be one attribute called message, and it's going to be of type string. And maybe just to keep this simple, I'm just going to add a couple of traits already. So derive, I would add debug, and what did I do? Derive, debug, and then deserialize. Okay, and that's really all I need to do for this. And now I define my endpoint. So again, it's going to be an async function. I'm just going to call this publish message, for example, and then it's going to take two things. One is going to be our app state, which is going to be of, again, web dot data, and then the data, of course, is going to be of type app states like this. And it's going to take this, and I want it to take another thing, and then of course the other thing would be what we defined over here, this nuts rec. So again, I'm just going to say web JSON, and then here I'm just going to pass my nuts rec. So this is going to be the kind of payload that should represent. This should represent our payload more or less. And then again, it's going to implement two things. So that's why I'm going to use a result. So if everything goes well, I would like us to return anything, whatever it is that implements a responder. And otherwise, we return an HTTP error. So this is going to be our error, the one we predefined already sometime in the past. And that's really all this function is going to take. So at this point, we have two methods as to how we can actually publish to um, our NAT server, and of course to the specific topic we want to publish. And what I'm going to do is actually just go ahead and implement the two possible ways, and then we try them out individually. So again, I'm going to take out our connection. Our connection is going to come from our app state, and from here we just simply go ahead and get our NATS client. And of course, because it's with behind the mutex, I'm just gonna come on. I'm just gonna lock, and of course unwrap. And if everything goes well, then we have access to our connection. And now what I'm gonna do again here, it's really pretty straightforward. What we can actually do here now would be to maybe just use this to just publish. So I can actually do something like, let me say match. I can say con.publish, and now I provide the topic. For the topic, I said I would like to publish to EasyDev2, and then the payload, and then of course I'm going to say maybe EasyDev2 publish, for example, just to specify where this is coming from. And then the payload, I'm going to say rec, that's 0, that's message. And maybe I'm also going to make this to string. No, sorry, I think it's already a string. So this is actually not needed. Okay, and now of course I need to, because this returns a future, so I need to await. And now I have two things to handle actually. So if everything goes well, what I would want to do simply be to return HTTP response of status OK. So I can wrap this, of course, within the OK block, and now say HTTP response, at OK. And then here, I'm just going to pass a body, and within the body, I'm just going to say something like message published successfully. Again, of course, before we do this, we might have done some operation, whatever, and then in the end, if everything goes as we expected, then we publish. Otherwise, we don't. Whatever it is we would want to do, doesn't really matter. So, but here again, I'm going to handle the error, a possible error, if everything or if the publishing didn't actually work out. So again, I'm just going to wrap this within an error block, and now I'm done my return my HTTP error, internal error. Actually, I'm just gonna maybe go in here and okay, I already have one here defined. As you can see, I called it nuts error. So that's what I would like to return here. Again, nothing fancy, nothing special actually. And we have an error here. Of course, yes, I can say to string. And now we should have, oh, sorry, I can actually do into here. That should be okay. And so now we have our endpoints, but now I would like to, of course, annotate this to specify which endpoint would be going to. So we're going to have a post. It's going to be a post. And the endpoint, I'm just again going to keep it simple. So it's going to be slash publish. And we'll need to, of course, bring in post. And that's actually, so here, maybe I can actually do something like this. Doesn't really matter. Because maybe I don't want this to just go to waste. So I can say something like, just keep a simple error. And I can, of course, do this way so we'll be able to see the error quite well. And then I close this off, and then we can actually return the error back to the user. So this is actually one simple endpoint we can create to handle this for us, pretty straightforward. And of course, to hook this up to what we already have, I'm just going to come over to API and maybe come to auth, for example, and then I'm just going to copy this, create a new file in here, and I can call this nuts.rs. And then I add this, of course, into my mod. I say pub mod nuts. And then in here, inside here, I'm just going to paste this, and this is going to take care of, I'm going to call this maybe nuts. So this is where we can define every endpoint relating to nuts. I can just call it get nuts services. And of course, for now, I'm just going to remove this authorization header from here because I don't want it to bloat the whole place. And in here, I need the endpoint we just created, which was the publish message, this one. And now I can actually just get rid of these other things. So this should go. This should go. What else? This should go. What else? So this should of course go as well. And I can remove this. And now actually remove this. We don't need that. And now we have this hooked up more or less. So our endpoint will actually be /nuts/publish. And now I can come back to our main file in here. And again, just to keep it simple, I'm going to take out this our token auth middleware. And then down here, I'm just going to create a new service. And then I'm just going to add our nuts service. As simple as this. So this is actually what I want us to have. And what we would now test, of course, is to see if visiting that endpoint actually publishes to this topic, and to also see if this helper function, which we have over here, is also able to catch that message as it comes in. So now I'm just going to come over to our test file, which is this HTTP file. I'm just going to copy the last thing we have in here, come down here, duplicate it, and I can maybe change this to nuts publish. And then of course I change it, so this is going to be nuts, and the last part is going to be publish. And of course we have the single payload here, attribute here, of course, which is string. called message. And here I just want to send my email, doesn't really matter. And I'm going to restart this server just to be sure that everything is behaving as we expect. And now I can actually send the request. And now you see we get if I come back in here to show you, so let's go back to nuts and come here. So this is also the message we have here. And maybe I do that one more time so we can also analyze, of course, the results we get back. So I bring this over here and then send the request one more time. And then you can also see here, if you're looking here, the content of the payload, of course, is what's coming in here from the request. So this is actually one way we can actually map these to or allow our endpoints, because again, of course, our endpoints are short-lived and also they are stateless. So it's the one easy way to be able to actually attach a live client to our NAT server. Of course, one easy way really would be to use the app state. So that way any endpoint would have access to it and then of course can use this as it wants to or as we want it to. So like I said, I would like to show two ways we can actually consume the messages that or more or less write into and publish and subscribe to our NAT server. So I'm just going to save this file and close it. So we can look at the other method. If you remember, in our app state, we actually added two things. If I go back to main, and if you look up here in our app states, you would see also we have this sender, because again, up here we created this channel. So it's also possible that we can, if it happens that we want to do other things or we want to do there are a lot of complex things actually you can actually do if you're doing something like this. But if it happens that we want to use the channel to also put our messages across without having the endpoint more or less have an access to the client and then publish to it, maybe due to some configuration or security issue or design pattern or whatever the case might be. What we can actually also do is to let the endpoint publish to a given channel, and then we can now have the channel again have another task more or less, listen to this channel and then get the messages out of them, and then this can now decide what it wants to do, maybe publish to a different topic or do other thing, or spin up a cron job or whatever. That is a really ton of possibilities that you can actually do with this the limits the possibilities are actually limitless. So let's look at this other possibility actually. So I'm going to collapse this again and maybe bring this down a little bit lower. And I would like to create a new function here. I'm just going to call it's going to be again an async function. I can maybe call it handle sender. And it's going to look like this. Actually, I'm going to copy this. It's going to look like this. The only difference, of course, is that we will also like to pass our receiver in here. So I'm just going to call this receiver like this. So it's going to be of MPSC and type receiver, and the type of data that would be sharing within this channel, of course, would be of type string. So, but at this point, once we have this, again, we can create our infinite loop one more time. And again, now instead of um, um, listening to is a topic or subscribing to a topic more or less, now we can listen to a channel. So I can say while let some, and then here I'm gonna call it again MSG for message. So this message is gonna come from our receiver, of course. I can say receiver that receive, and again it's gonna give us a future, so we await it. And now again here I can maybe print a message, and I can say something like message received, and here we can just simply show the message that we got. Okay, and then but once we have sorry, should be MSG like this, and we have some error. Of course this is mutable, so I have to make this mutable as well. So mutable, so this should be fine. And now, so once we have the message, what we can now do again would be to simply publish. So I can say match. I can match this so we can see how things progress. So now we can say client.publish. And now again, I'm going to maybe publish to easy dev 2. So what we're doing here basically is we get the messages from the channel and then we publish into a topic. So now we already have subscribers subscribing to those topics, and they will still process the topic as before. As simple as that. And now over here, we just take our message, and I can do dot into, and that's really it. And of course, again, we get a future, so I await it. So dot await. And now we should, of course, be able to take care of our two arms. So if everything goes well, if we are able to successfully publish our message into the to a NATS topic, again, I'm just going to put it a message here that says successfully published message. And if we get an error, again, I would like to show the user what's possible error that might have occurred. So again, I'm just going to add the message here and say something like error. And now we can simply display the error that we got. So as simple as this is something I would like us to have, as simple as this. And now again, I'm just going to come up here. Maybe I'll copy this guy again, bring it down here. And now I can say handle sender, and I replace it with this. And of course, we now have our receiver over here, and then we can simply pass this down here. So the first thing is the client, and of course, the second thing would be our receiver. And that's really another way we can actually consume our messages. So now what we can do is to come over here to our handler, which is what we have over here. And then we try to make sure that instead of having this published to this, what we can simply do is to write into a channel and then to see if actually we get our message from the other end. As simple as that. And to do that again, it's really pretty straightforward. So I'm just going to come up here and I can say app state. I can say dot sender. Again, I'm locked because it's behind the mutex. Dot unwrap to handle any possible error we might have. And now I simply just call send. So in here, we simply just send the message that we have within the payload. So I can say request.0.message, and I can simply say to string. And so we have, of course, this would also return an error. So sorry, would return a future. So now we can again await this and maybe handle the error as well. We can also handle the error the way we are doing it here. But for now, I'm just going to keep it simple. But the point is that I should be able to actually take this part out and maybe just copy something like this. Let me copy this part, copy something like this, bring it down here. So the point is that I should be able to still do something like this, and our message will still get to the topic where it needs to go to. It would still be published to the topic, and the subscriber will still get this message and process it. That's really the point. So we now have the option to do something like this or do something like this. It's really is up to you depending on what you would want to do. So let's just go ahead and test this up to see if this still works, and then we can wrap things up. So let's test to see if everything is behaving as expected. So I'm just going to go back to this HTTP file, and then we'll send a couple of requests. And we actually see our messages. I think we might have some error. So let me go back to main. And here also, if you look here, we have actually written this wrongly. So again, if you remember, this guy here is listening to easydef dot whatever it is as follows. So I'm just going to also do exactly like what we have here. So here we are publishing to easydef2 that's publish. Again, I'm just going to come in here and make it like that as well, so that that would also get through. And now I clean this up, I expand this so we can have more real estate to see what's going on. And I also open our HTTP file and scroll to the bottom so we can test things out. And now, so I send a couple of requests, and of course, you see as before, our message actually gets through. We can send this as many times as possible as we want. And you can see over here, our messages always gets through to where we want it to get. So like this is one of the cool things I really wanted to show you, and of course introduce you to NAT server in case you've never heard of them before. There are lots more complex things, trust me, you can do with this. In fact, the idea from the developers is actually that this could actually compete toe to toe with already mature services like Kafka. Again, I'm going to leave a link to most of some articles, and of course to their homepage, so you can read things up for yourself and maybe discover them as I did. But again, like I said, there's a lot more you can do with this. You can do things like key value stores, key value store, like you would with resources like say Redis. It also offers object store, so you can also have store blob files, for example. There's a lot more you can do. Again, apart from just doing this, it also allows you to have like spin up a couple of clusters to have like instead of also doing it from the command line that we already did, there's also option to write like a nats config file, and then when you start the file, you start the server, you actually point it to the config file to take most of the configurations you already have in there. You can communicate and of course manage different clusters. You can of course have like multi-cloud, like there's a lot more you can actually do with this. And so again, I really encourage you to read things up for yourself and also maybe discover them. Anyways, guys, that's really all I wanted to show you in this series. I tried to keep it as short as possible. But again, if I was really too fast for you, of course, take your time, go back and look at the video again. And of course, if anything is not clear, please feel free to reach out to me. I will get back to you as quickly as possible. And anyways, guys, that will be all for now. And I hope you actually found this quite useful for you because I did myself. That will be all, guys, and we will see each other very soon. And until then, have a lovely evening.